system introduction, and network connection. Press and hold the power button to turn on the device. The main screen displays system settings, USB, instrument setup, files, and new measurement. For first-time use, it is recommended to connect to the internet and log into your account by receiving a verification code via mobile phone or email. The first login will also register your account. The mobile number or email address will be used as the username, and they can be used to log into the Admt data management system on the web. You can log into the same account on your phone or PC for cross-device data processing. Without an internet connection, only basic measurement and drawing functions are available. To connect to Wi-Fi, click System Settings, then click Wi-Fi to search and connect to a nearby Wi-Fi network. After connecting to the network, click System Settings and then Login or register. You can choose between mobile login or email login. It is recommended to use the more convenient mobile login. Log in by sending a password to your mobile number. The password remains valid until it is reset. This account and password can be used to log into the same app on different devices. It is recommended to obtain and save the password once. Instrument setup. The Zn series groundwater detector uses a USB connection. Before use, ensure that the connection mode is set to USB. On the main screen, click USB, then select the USB option. After the connection is established, the system will automatically jump to the setup screen. The instrument setup screen displays equipment model and ID number, data processing, and various measurement parameter configurations, depending on network connection and login status. The device has two different configuration methods. Before configuration, confirm the connection mode is set to USB and the device is properly connected. We recommend completing survey cable deployment and device connection before instrument configuration. When the account is not logged in, the parameters for data processing and AI analysis will use default configurations based on the current device model and cannot be modified. After logging in, users can customize settings for data processing and AI analysis. You may use default parameters provided by ID or make targeted adjustments according to local conditions. Sampling channel num. The system will automatically recognize the number of connected channels, or you can set it manually. Stacking times. Set the number of stacking times for the measurement. Start depth and end depth. Set the depth range for the current measurement as needed. After completing the setup, click Settings, then click Confirm to proceed to the new measurement screen. New measurement. Set the project name. Enter the name in the pop-up window or click Select Item to choose an existing project. Set survey line num, line spacing. Set measurement mode when no survey line or sensor is connected. The default measurement mode is MN, after connecting survey lines or sensors, or when switching between them. First set the channel number and sampling channel num under Instrument Setup. Then click Settings to identify the measurement mode. Click Confirm to enter the measurement screen. Click Measure to perform a channel check, which will detect the connection status of all channels. In the Channel Check pop-up window, the connection status of all channels will be displayed. Red indicates an abnormal connection, and the channel needs to be checked. Blue indicates a normal connection, and you can proceed with the measurement. Click Confirm to start the measurement. The top of the screen displays a line chart of the current measurement results, while the bottom shows the raw data. A, B, C, D, and E represent the point number, depth, apparent resistivity value, current channel number, and total number of channels, respectively. After completing the measurement, click Auto Draw to enter the drawing screen. O to D is the old version of the contour map, while N to D is the new version. Both types of maps have options for vertical contour map or plane contour map. A is the AI analysis function. Before using it, you need to set the AI analysis parameters and select the survey line. You can also load previously analyzed data by selecting history. LG is the line chart drawing function, where you can choose to generate a plane line chart or a vertical line chart. 3D is the 3D contour map drawing function, where you can choose between 3D or 3D slices. In 3D slices, you can flexibly slice the image by setting sounding, survey line, or point increment. File viewing. Click Files to select a file for further drawing. Click Backup to backup data to the cloud. Click Data View to view the raw data of the selected file. Click Cloud to access files stored in the cloud for sharing, downloading, or deletion. Device Settings. Click System Settings to enter the System Settings screen. Here, you can configure user information, language, and device functions. In the top row, you can log in or out of your account, set user personal information, or scan a QR code to log into the AIDU data management system on the web. Device binding. Bind the current device to your account or unbind devices from your account. Language. Choose the display language. The AIDU Water app offers 10 languages for users to select. Bluetooth, Wi-Fi, hotspot, mobile data, and screen brightness. Configure the corresponding device functions. About Us provides information about the AIDU Water app and allows you to update the software version. System Messages. View AIDU official notifications. Single Channel System Electrode Connection Method. Connect the cable to the main unit. Insert the M&N electrodes into the ground. Connect the electrodes to the survey line cable. The survey point is located at the midpoint between the two M&N electrodes. Tap Measure on this point. Data acquired will be displayed once the measurement is completed. Then move the M&N electrodes along the same direction at a fixed interval to the second survey point. Tap Measure to acquire data from the second point. Repeat the process until the entire profile is measured. Single Channel System Electromagnetic Sensor Connection Method. Connect the sensor to the main unit. Place the sensor flat on the ground and start acquiring data. The survey point is directly beneath the sensor. The orientation of the sensor is not critical but must remain consistent across all survey points on the same survey line. After completing data acquisition at this point, move the sensor along the same direction at a fixed interval to the second survey point. Tap Measure to acquire data on the second point. Repeat the process until the entire profile is measured. 12-channel system connection method. Connect the measurement cable to the main unit. Extend the cable along the survey line and insert the electrodes into the ground. Clip the cable onto the electrodes. Begin acquiring data when ready. The 12-channel system can simultaneously acquire data from 10 survey points. Each survey point is the midpoint between M&N electrodes. The second electrode position equals first survey point. The third electrode position equals second survey point. Repeat until the entire profile is measured. 24-channel system connection method. Connect to 12-channel measurement cables together. Connect the cables to the main unit. Extend the cables along the survey line and insert the electrodes into the ground. Clip the cables onto the electrodes. Begin acquiring data when ready. The 24-channel system can simultaneously acquire data from 22 survey points. Each survey point is the midpoint between M and N electrodes. The second electrode position equals first survey point. The third electrode position equals second survey point. Repeat until the entire profile is measured. 36-channel system connection method. Connect 3 12-channel measurement cables together. Connect the cables to the main unit. Extend the cables along the survey line and insert the electrodes into the ground. Clip the cables onto the electrodes. Begin acquiring data when ready. The 36-channel system can simultaneously acquire data from 34 survey points. Each survey point is the midpoint between M and N electrodes. The second electrode position equals first survey point. The third electrode position equals second survey point. Repeat until the entire profile is measured. 48-channel system connection method. Connect 4 12-channel measurement cables together. Connect the cables to the main unit. Extend the cables along the survey line and insert the electrodes into the ground. Clip the cables onto the electrodes. Begin acquiring data when ready. The 48-channel system can simultaneously acquire data from 46 survey points. Each survey point is the midpoint between M and N electrodes. The second electrode position equals first survey point. The third electrode position equals second survey point. Repeat until the entire profile is measured. 60-channel system connection method. Connect 5 12-channel measurement cables together. Connect the cables to the main unit. Extend the cables along the survey line and insert the electrodes into the ground. Clip the cables onto the electrodes. Begin acquiring data when ready. The 60-channel system can simultaneously acquire data from 58 survey points. Each survey point is the midpoint between M and N electrodes. The second electrode position equals first survey point. The third electrode position equals second survey point. Repeat until the entire profile is measured. Multi-channel electromagnetic sensor connection method. Connect the sensors to the main unit. Extend the cables along the survey line and place each sensor at its corresponding survey point. Begin acquiring data when ready. A high-density cascaded sensor system can simultaneously acquire data from multiple survey points. One sensor equals one survey point located directly beneath the sensor. Repeat until the entire profile is measured. Straight line profile parallel layout method. The straight line profile is the most common layout method. Multiple parallel straight line profiles form a multi-line survey enabling rapid determination of subsurface target orientation. First hypothesize or estimate the target's orientation in vertical projection, then lay survey lines perpendicular to it. Typically 2 to 3 survey lines suffice to identify anomalous body's orientation. The number of straight line profiles depends on the target's length. The spacing between profiles, called line spacing, should generally be less than or equal to the target's length. Cross or oblique intersection layout method. If space constraints prevent parallel profiles after measuring one straight line profile, use straight or angle intersections for the second profile. Combined intersection methods help confirm the target's presence and estimate its approximate orientation. Circular profile layout method. For confined spaces or near point source interference such as transformers or signal towers, deploy circular or semicircular profiles centered on the interference source or site midpoint. This quickly identifies target location and orientation. Precautions for instrument use. Regularly check the battery level and keep it charged. Ensure sufficient power during operation, and turn off the device after use. Use only the original charger. Non-original chargers may damage the instrument during transportation or use. Handle the device with care to avoid severe shocks, impacts, or water exposure. During measurement, maintain maximum possible distance between the main unit and cables or sensors. After each use, clean the device and electrodes, and store them in a dry, well-ventilated place. If MN electrodes or electromagnetic sensors are not connected, the corresponding channel will display in red during channel detection, indicating abnormal connection. In this case, please check the connection of electrodes or sensors in MN mode. Also verify that the electrodes are properly grounded. If measurement data from all survey points are abnormally low and consistent, there may be a device malfunction. Contact after-sales support for verification.